Hello everyone. Today we will discuss about the design of cylinder and pressure vessel, which is a part of mechanical system design subject. So how the cylinders are going to design and how the pressure vessels are going to design, that we are going to see here. So this unit mainly includes the two parts, that is the design of cylinders and a design of pressure vessel. So in design of cylinder, we have two types of cylinder, that is thin cylinder and thick cylinder. That is nothing but the inner diameter to the thickness ratio. Uh, Based on that, we are classify the cylinders as a thick cylinder and thin cylinder. Then Lam's equation. Then we are having Clavirion's equation, Perrin's equation. Then design of hydraulic and pneumatic cylinder. Then concept of auto frittage, compound cylinders. Then cascades, joints in cylindrical vessels, etc. So this type of topics we are going to cover in design of cylinder. Then we are going to next we will see the design of pressure vessel. In that mode of failure in the pressure vessel, then unfired pressure vessel, then classification of pressure vessel as per IS 2825. Then categorize and types of the welded joint, weld joint efficiency. Then stresses induced in the pressure vessel, materials for pressure vessel, thickness of cylindrical shells and design of enclosures as per code. Then nozzle design and openings in pressure vessel. Then reinforcement of openings in shell and enclosures. Then area compensation method. Then types of vessel supports, etc. So these are the topics that we are going to cover in this unit. Now we will see some basic of pressure vessel oblique cylinder. So a closed container to hold the gases or liquid at a pressure different from the ambient pressure. That device is called as a pressure vessel or cylinder. Then it is a mechanical device used to store or receive or to process or to carry the fluid. That is called as a pressure vessel or cylinder. If the pressure difference is greater than 0.5 bar, then that fluid can be stored with the help of the device called as a pressure vessel or cylinder. Closed vessels of diameter greater than 150 mm is called as a storage vessel, which consists of hydraulic devices, engine cylinder, pipes, where the diameter of vessel is greater than 150 mm. So that will be called as a storage vessel or hydraulic device or engine cylinder or pipelines, etc. So basically cylinder or pressure vessel, it is the mechanical device used to store, receive, process, next is a classification of pressure vessel and thick cylinder. So the thin walled pressure vessel is nothing but the ratio of diameter to thickness. If it is greater than or equal to 50, then such a vessel is called as a thin walled pressure vessel. Then the derivation of formulas for stresses in thin walled pressure vessels are based on the assumption that the stresses are constant throughout the wall of the vessel. Then radial stresses are neglected in case of thin walled pressure vessel. That is nothing but also it is a thin walled cylinder, we can consider it as depending on the diameter to thickness ratio. Then thick cylinder are nothing but the pressure vessel is considered thin walled in terms of a diameter. If it is a diameter to thickness ratio, if it is a less than or equal to 15, then that will becomes under the thick cylinders. Then also here radial stresses are considered in case of thick cylinder design. So here you can observe one diagram. So in that you can observe the Pi is the internal pressure, T is the wall thickness, and Di is the inner diameter of the cylinder or vessel. Next, the stresses induced in the thin cylinder. So there are the types of first stress induced in the cylinders is nothing but a circumferential stress, or it is also called as a hook stress, or it is also called as a tangential stress. So it is nothing but whenever the stress is exerted circumferentially on the every particle in the cylinder wall, this can be imagined as a bound band surrounding a barrel. So when barrel expands, the band stress and undergoes stress. So you can observe in this image, this is the length of the cylinder, which is a thick cylinder. Then T is the thickness of thin cylinder. Di is the inner diameter of the cylinder. Pi is the internal pressure exerted inside the cylinder. And you can observe here sigma T is the stress induced in the cylinder. So along the circumference of the cylinder, the stress is induced. So such type of stress induced is called as a uh, circumferential stress. So the circumferential stress for thin cylinder is calculated by the formula sigma T is equal to pi di upon 2 times uh, eta L. So the pi is the inner diameter, pi is the internal pressure in the cylinder, di is the internal diameter of the cylinder, T is the wall thickness of the cylinder, and eta is the weld joint efficiency along the length of the cylinder. So in this way we can calculate the, or by using this formula we can get the circumferential stress in the thin cylinder. Next, stress is a longitudinal, or it is also called as the axial stress. So along the axis of the cylinder, if the stress is induced, then such type of stress is called as a longitudinal stress. So here you can, in this diagram, you can observe that you can see the cylinder. Then Pi is the internal pressure in the cylinder. Di is the inner diameter of the cylinder. T is the wall thickness of the cylinder. And along the axial direction, the stress is induced. That stress is called as a longitudinal or axial stress, that is denoted by a sigma L. So here the Pi into projected area is equal to the stress into the resisting area. So this is the formula. After simplifying this formula, we will get the longitudinal stress is equal to Pi di upon 4 times T. So here sigma L is the longitudinal stress, Pi is the internal pressure, Di is the inner diameter, T is the wall thickness of the material, wall thickness of the cylinder. So you will get the longitudinal stress, and if you consider the for the weld joint efficiency, so along circumferential direction we will get the weld joint efficiency as a eta C. So the sigma L is equal to Pi di upon 4 times thickness into the eta C. So this will be called as a efficiency, weld joint efficiency along the circumferential region. So in this way you can calculate the longitudinal stress for the cylinder. Next, a radial stress in thin cylinder. So as along the internal pressure is acting and external pressure at the outside boundary becomes 0. So the along the radial direction the internal pressure value is very less. So the radial stress value is also going to less. So the radial stress is neglected in case of a thin cylinder. Then for a thin spherical shell subjected to the an internal pressure Pi or P, so we will get the thickness, or we can calculate the thickness of that thin spherical shell by using the formula P into D by 4 times sigma T, where P is the pressure, inside pressure, or pressure acting inside the spherical shell. D is the diameter of the spherical shell. Then sigma T is the tangential, or we can say hoop stress acting on the circumference of the spherical shell. So from this you can also get the tangential stress or thickness of the material. So we will get the 4 times by solving this equation. So this will be the area on which actual pressure is acting, and this is also going to the circumference of the spherical shell. So pi into dt is the circumferential area, or the restricted area for the spherical shell. So from this we can get the thickness of the cylinder. Then next point is a thick cylinders shell subjected to an internal pressure. So when the ratio of inner diameter of the cylinder to the wall thickness is less than 15, the cylinder is called as a thick cylinder, and or it is a simply thick cylinder. Hydraulic cylinder, then high pressure pipes and gun barrels are examples of the thick cylinder. Means if the inner diameter to the wall thickness ratio, if it is less than the 15, then that cylinder is called as a thick cylinder. So in case of uh, thick wall cylinder, the stress over the section of the wall cannot be assumed to be uniformly distributed. So they develop the both in tangential as well as the radial stress with the value which is dependent upon the radius of the element. So the radial stress is given as minus pi di square by do square minus di square into bracket do square upon 4r square minus 1. So this is the formula from which we get the radial stress for the thick cylinder. Then we'll get the tangential stress for the thick cylinder by using this formula pi di square upon do square minus di square into bracket do square upon 4 times r square plus 1. So in this way we can get the uh, tangential or circumferential, or it is also called as hoop stress for the thick cylinder. Then we'll get the longitudinal stress which is equal to pi di square by do square minus di square. So by using this formula, we'll get the longitudinal stress. So for the thick cylinder, sigma r is minus pi. So we are going to neglect the sigma r. So we'll get only sigma t is equal to 2 times pi di square by do square minus di square, where in this case we will get the circumferential stress or tangential stress or hoop stress for the thick cylinder by using this formula whenever that thick cylinder is going to subjected for the internal pressure. So in this diagram you can observe that clearly. So this is a thick cylinder where pi is the internal pressure acting on the cylinder, di is the inner diameter of the cylinder, then do is the outer diameter of the cylinder, and po is the external pressure acting on the thick cylinder outside. So that value will be equal to 0. And also pi is acting along radial direction becomes very less. So we are going to neglect the radial stress. Then the radius for the calculating the outer surface of the cylinder we can get by using the half of the outer diameter of the cylinder. So from that we will get the r value. So by using this, we can easily calculate the uh, stress induced in the thick cylinder whenever it is subjected to the internal pressure. So in next lecture, we will see the different equations like Lamè's equation, Clarinot's equation, etc. So thank you for watching the design of the cylinder part.